Hi everybody, thanks for being here. I know that's a bit early, but I'm Sébastien Deleuze. I am one of the Spring Framework core committers, and today I would like to talk about runtime efficiency with Spring using Spring Boot 3, Java 21, and CDS. So first, let's start by talking about what do we care about runtime efficiency. I guess we all want to have cheaper hosting, and we want to have cheaper instances to run our Spring Boot applications. Using less CPU, using less memory, using less resources is good for sustainability and really makes sense in the current world. And deploying your Spring Boot application will usually involve containers. Either you are using Kubernetes, you are deploying containers in the cloud. And so we are going to talk about today about how to achieving the most efficient possible containers using Spring Boot and the JVM. Of course, you can also use native image. I have been leading the Spring Native project that has now incubated and is now integrated as the official native image for Spring Boot. But today, we are going to focus a bit more about native image, about JVM. So we have different kinds of optimizations possible. We can optimize the startup time. Typically, we could want instant startup in order to be able to scale to zero and provide serverless style workloads. But even without scaling to zero, I guess when we deploy Spring Boot application into cheap servers with 1 or 2 CPU, on big application, it can take several seconds to start, and you want to minimize that because you want to be able to scale up pretty fast, and you don't want to wait too long before it's up. So that makes sense. We also potentially want to warm up faster our JVM. We likely all know that you need to warm up your JVM in order to get peak performance, and sometimes it can take some time. If you are just running your workloads for a short period of time, your JVM may be not hot enough to provide the peak performance expected. There is also the scalability aspect. We want to provide, we want to be able to serve more workloads with less CPU and less memory. And the memory consumption is also important because when you are buying an instance, you will have a certain amount of memory, and you want to pack the maximum of Spring Boot instances into the same amount of memory. So I think since Spring Boot 3, we have a big focus on efficiency. If you have a look to the main features provided by Spring Boot 3, look, we have worked on the native support. Honestly, it has been a huge effort, and it's now available as a first-class feature as of Spring Boot 3.0. The biggest part of the native support was not the native support itself. It was working on the Spring ahead-of-time optimizations that basically perform some computation and some optimization at build time and allow the native image to have a tiny footprint. But we can also use the Spring IoT optimization on the JVM. We are going to see that today. Spring Boot 3.1 was a bit of focus on developer experience because we spent so much energy on native that, a bit of love for test containers and Docker Compose. Honestly, I'm a big fan of those features. We can stop using H2 embedded database that provide differences compared to the production database, etc. It's super nice for external services. I think this is a big win in terms of developer experience. But just after Spring Boot 3.2, big focus on virtual threads. Spring Boot 3.2 is the first Spring Boot version provided official support for virtual thread. You need to enable that with a flag, but it's available. And we have worked on Project Crack that I presented last year. I'm going to talk again about Project Crack today. And Spring Boot 3.3 that has been released a few days ago. We provide CDS class data sharing support. Big focus on that today. And that's a bit off topic, but if you have not seen, check the new Spring Boot documentation. Basically, before there was a single page versus multi-page documentation, and now we have a unified documentation with built-in search engine. I know it changed a bit your bits, but I think that this is a big improvement, and we try to unify the documentation across the Spring portfolio in order to provide you better documentation across the portfolio. So quite a lot of focus on runtime efficiency, and it's not about the big features like that. We are also working a lot on small improvements. Like I said in the keynote, we have created this Spring Runtime Efficiency Working Group that is working portfolio-wide on improving various aspects, and you are going to see we had a few surprises. So what is class data sharing? So class data sharing is a pretty old and mature technology. It's included in the JVM, I think, as of Java 9. But it has been gradually improved. And I think as of Java 17 and in Java 21, it's even faster than in previous version and very interesting to leverage. But that's a bit of a hidden gem inside the JVM. So the principle is that you are going to do a training run of your application, create a CDS archive, so app.gsa, and then providing a special parameter to the JVM, you are going to be able to start faster your application, consume a bit less memory, and with a very few constraints. So I think this is a big difference compared to Crack, but we are going to see more detail about that. In Spring Framework 6.1, we introduced support for automatically shut down your application context before starting the lifecycle. And that's a very good fit with CDS, because basically what we want with CDS, we want to move forward enough in the startup of your Spring application to load all the classes, but we don't want to connect all the remote services, etc. And so basically, and this is exactly the same extension point that we use for Crack. So basically, we start the Spring Boot application, we instantiate the bin, but we shut down. And when we shut down the application, basically the CDS file is created automatically, and that's a good fit. So I'm super happy because I think we landed this feature in Spring Framework 6.1 like 1 week before the release, and that allowed Spring Boot 3.3, which is based on Spring Framework 6.1, to provide this feature. So an update of my table with colors. So we are going to spend a bit of time on that to basically compare the various options, because I mean, there is GraalVM native images, there is Project Crack, there is CDS. We are not just here to add new technologies and give you too much complexity in terms of choice. So I'm going to try to share my opinion. Yours may be different, but I'm going to try to provide you insights to know how to choose the technology we want to use. So native, like I shared in the keynote, honestly, yeah, the adoption is pretty high. I mean, from the beginning, I'm a big fan of native, but I'm also realizing that it's sometimes a lot to ask because there is some compatibility issues, the build is different, a bit heavy, etc. But pretty impressed about how the Spring community is embracing native. So instant startup, few milliseconds, super fast startup. Fast warmup because you directly get peak performance. You don't have any warmup because you spend more time during the build time. You don't have any JIT, so you get immediately peak performance. So good fit for scaling to 0 and shut down your instance when it's not used. Optimal peak throughput, so it's important. So there is 2 versions of GraalVM. GraalVM Community Edition, which is also used by Liberica Native Image Kit, and Oracle GraalVM. It's a new name of Oracle Enterprise, GraalVM Enterprise Edition. It's now available with the same condition than the Oracle GDK, so basically you can use it to provide services to your customers for free without support, but you can't use it to ship a container, ship an executable to your customer. So you can't ship an artifact to your customers with this Oracle GraalVM. But Oracle GraalVM is pretty good because it provides better peak performance compared to the Community Edition variant. And also it provides what is called profile-guided optimization, which allow to reach a peak throughput that is as impressive than a hot JVM. Because generally, GraalVM native images have lower throughput than a hot JVM. Okay. So memory consumption, good point. Reduce memory consumption, very nice. Compilation, pretty bad, heavy and slow, and architecture specific. So if you are shipping containers, maybe that's not a big issue because you will ship basically something that is in your Linux container. Compatibility issues, for some people it's red, for some people it's orange, it depends. Basically, GraalVM native images require explicit configuration for reflection, proxies, etc. Spring is configuring a lot of that for you. You just have to leverage the libraries that are not supported by Spring, maybe your enterprise-specific libraries. And I know that in the real life, in real project, it could be a bit challenging. So yeah, for some people, it's okay-ish. For some people, it's very hard. It depends on the project. We are collaborating with the GraalVM team to improve that and make GraalVM native images more compatible with the regular JVM behavior. We will share more news about that later. Security all good. Some people from GraalVM team even claim that the native image is more secure than the JVM because you need to explicitly configure any reflection invocation. So yeah, you are more constraints in terms of that aspect. And I added a column regular Java distribution. So GraalVM distribution is required to compile your native image, but it's not needed at runtime, so that's not really a drawback. But it's not regular JVM. Crack that I presented last year, so instant startup, pretty close to GraalVM in terms of startup time. For the warm-up, you need to do a training run. So you need to apply some workload during the training run. Can be challenging because you need to basically connect to your remote services. You need to apply the right workload to get that right. And it's pretty hard to directly integrate Crack in your Kubernetes cluster, for example. There is a lot of challenges involved. Optimal peak throughput, it's a regular JVM. No gain in terms of memory consumption. Compilation is fast, it's a regular JVM. But there are blocking points. Not always blocking, but very hard points that make Crack pretty hard to use in enterprise context. There is complex lifecycle issues because a bit like CDS, you are going to do a training run, you are going to do a checkpoint, and then you are going to restore the execution. It's not a new startup, it's restoring the execution. That creates a lot of challenges in terms of lifecycle with JVM libraries, connection pools, Spring itself, and people maybe expect that basically the configuration will be magically resetted during restoration using all your configuration on your cloud environment or your Kubernetes cluster, but that's not the case. It's possible with Spring Cloud context, Spring Cloud config, but you need to have proxies, etc., explicit configuration with refresh scope. So it's possible, but it's hard. Okay. Another issue, we try to have self-contained containers that are optimized. We don't necessarily want to have a very tight integration with the platform. And again, integrating Project Crack with the Kubernetes cluster, it's a bit challenging, believe me. So basically, we are tempted to put the serialization of the memory that is this snapshot file into the container, but you are leaking secrets because everything in memory will be serialized in this file, and if you ship that with your container, you have security issues. And that's a big issue because Crack is very powerful, super fast startup, but it's a bit brutal. Okay, it's based on CREU, a Linux project that serializes the memory representation of a running instance on disk, and it serializes everything. Okay, so it's so secret leaking in snapshot is a real issue, and a few people were surprised. So now I say that explicitly. Crack is Linux only. Okay, CREU is a Linux technology, and if you are running on macOS, so sure you can use Docker and run Crack, but it's a Linux-only technology, and I'm not sure it will be integrated into the regular JVM at some point because that's a bit specific. It's, so let's see, but there is a few blocking points. And today I would like to focus on the technologies that are easier to use, and hence the focus on CDS. So with CDS, we have slightly less benefits in terms of startup time, but already quite good. We have 1.5x faster with just CDS. 2x with Spring IoT, could be more, could be less, but basically this is the order of magnitude. You are going to have training run capabilities with Project Leyden. I'm going to talk about that a bit at the end of the talk. Optimal peak throughput, this is a regular JVM. Memory consumption is slightly reduced, not as much as with native, but more than with Crack. Fast compilation, regular JVM. So there is a training run with custom configuration, but this is much, much easier. We don't have any lifecycle issues because with CDS, we are going to do this training run, close our application, but when we restart, we start a clean startup of your application. So you don't have any lifecycle issue with your lifecycle. It's a clean startup, and also if you miss some classes, etc., it will not break like with native. You are missing reflection, etc. You will just miss the CDS optimization for this specific class, and the startup will continue. So it's much, much easier to use. Security all good, and this is available in our Java distribution since Java 9, so no problem, you already have it. So I guess the gist of what we propose, and of course, feel free to use Crack if you want, no problem, but we tend to recommend JVM with CDS because that provide better efficiency with a few constraints. Okay, so pretty easy if you are just using regular JVM, and if you are okay to deal with long build times, compatibility challenge of native. Native is a very good fit as well, but maybe not for the majority of use case. So Spring Boot 3.3 introduces CDS support via 2 new features that I'm going to present today. The first new feature is this capability for executable jar to auto-extract themselves. I think that's pretty important, and I really like this feature because I know that a lot of people run on production directly executable jars. It's not the most efficient way to run your Spring Boot application. We are partially faulty. We have added some documentation about that, but there was not real feature. We were asking people to unzip, unjar their executable jar. Buildpack is doing that for years, of course, but if you are deploying Spring Boot application on production, please do not just do java-jar my executable jar. You will consume a bit more memory, startup will be a bit slower, etc. It's better to unpack, okay? So previously we were documenting that, and nobody read that much the documentation, and we added that a bit late. But now you have a first-class feature. So basically, the capability we ship the capability for an executable jar to extract itself. Okay, so you don't need any tooling. You even don't need to install unzip on your container image. You just do java-d jar mod equals tools. You specify the jar, extract, and it will auto-extract. You can specify a directory if you want, and that will create. So we have our executable jar that get everything in it. Now we get a small jar, same name, just basically your application classes, and the class path is defined and ordered via a manifest file. So this is a little trick we are using to have the ordering of the class path that it still retain. And the libraries are directly files, and the JVM is able to optimize much more the class loading, and this is natively CDS compliant. So executable jar are not CDS compliant. The new layout is designed to be CDS compliant, but even if you don't use CDS, please use that thing if you are not using Buildpack. So we are going to see a quick demo that I have recorded. So we are going to build our application, okay? We are going to run it. So this is, I'm running the regular executable jar. You see that we start in close to 2 seconds, okay? 2 seconds startup. Now, we are going to use this new capability for an executable jar to extract itself. We are going to see the files. So you see that we have the lib directory with various dependencies and the small jar. We have all our dependencies in the lib directory directly as files. And then I'm going to run our application with the training run of CDS, exiting automatically the application after the creation of the bins, but before the lifecycle. It's going to create the CDS archive, so you can see the application.gsa. Okay, and now we are going to start our application specifying with the CDS arguments GSA file with the other one, and you can see that basically we divide by 2 the startup time, and the effort is not huge. There is small configuration needed for some use case, but you will see it's pretty easy. Again, let's talk about the ratio between the effort we spend to optimize our application compared to the benefits. That said, if you are doing things manually, be careful. CDS can be a bit tricky because CDS assumptions are easy to break. If you are copying files after extracting it, it will break CDS assumptions because it's going to change the timestamp, so you can copy keeping the timestamp, but it's easy to forget. If you are not using exactly the same JVM version to do the training run and the optimized run, CDS assumptions will break. So yeah, you need to be very careful, and this is why I like this Buildpack support, and maybe you can also do that with Dockerfile or Jib or whatever technology you are using. But it's good to be in control of the full chain of doing the training run and running your optimized application, because again, CDS is easy to use, but it's easy to break CDS assumptions. So we have provided CDS support in Buildpack that basically leverage Spring Boot 3.3 capability to self-extract this executable jar. Buildpack is going to run automatically the training run when creating the container image. Is going to ship the CDS archive in your container image, providing a self-contained optimized artifact. Slightly bigger, but we are going to see that we are going to make it smaller a bit later. And the increase is not huge. and automatically appends the CDS argument in order to run your application in an optimized way. So that's good because we are in control of the full chain of doing the training run and the optimized run, and this is done via Spring Boot and supported out of the box because Paketo Buildpacks is this open source project that allows Spring Boot to create container out of the box. So the exercise we are going to do today is to optimize Petclinic, the Spring Data JDBC variant, in order to add CDS support, but also much more other efficiency improvements. So you have this repository. I have put one commit per optimization. You have the main branch that is using Dockerfile. You have the Buildpacks branch that is using Buildpacks. And you even have a pre-main branch that is using Project Leyden optimizations, so you can get a preview of what is coming. The Buildpack branch is only compatible right now with my Mac M2. We need to fix a little bug to basically, you need to modify a bit the configuration to make it work on x86, but feel free to have a look. So we are going to see that we are going to start from Spring Boot 2.7 Java 8. So we have a Petclinic project. It's using Maven with Docker files, etc. We are going to check the sources. So it's regular Petclinic, the Java version with the Petclinic application class. We are going to check that we are using Spring Boot 2.7, we are using Java 8, and we are using Spring Data JDBC. So we are going to check, we are going to use a Docker file with the bad way to run Spring Boot application on production, just java-jar, the executable jar, and we are going to improve that. And the Docker file and the Docker compose file that allow us to run the database and the application. So if we start this Spring Boot 2.7 application, you see it start in 2.6 seconds basically, and we are going to optimize that by basically first upgrading to Java 21. So Spring Boot 2.7 is supporting Java 21, so we advise to first upgrade to Java 21 before upgrading Spring Boot itself. So should be good. So we are changing the SDK manager version, the SDK manager to use the Java 21 version. We are changing our Docker file to use Java 21, and we are changing the POM in order to use Java 21 as well. Then, second step, we are going to upgrade to Spring Boot 3.3. In practice, in your bigger application, feel free to read the upgrade notes. There may be other challenges, but basically, the gist of it is upgrade the version to 3.3. You need to migrate from JavaX to Jakarta packages because Spring Boot 3.3 is using Jakarta dependencies, and you should be good. And upgrading to Spring Boot 3.3 is an enabler for enabling the efficiency features and improvement that I'm going to show. So the first one is to enable virtual threads. There was some challenges a few months, years ago, because basically some JDBC drivers were not ready. There is still improvement to be made, so I don't claim that the whole JVM ecosystem is virtual thread friendly, but based on the figures we see, it seems that it's a gain for almost all use cases, and you will see there will be also big gains for some use cases. So we tend to recommend upgrading, enabling virtual threads. Then we are going to move database in it to the container because, here we are trying to optimize the startup time, the efficiency. Usually, upgrading your database schema is something that you do one time after an upgrade. You don't necessarily want to do that each time on production. That's not necessarily best practice. So here we are going to move the database initialization at Docker compose level and just remove the initialization of database at Spring level. You will see that will also help a bit for CDS. Now we are going to switch from Dockerfile to Buildpacks. You can use Dockerfile if you want, but we are going to leverage the CDS support and the new Spring AOT support in Buildpacks as well. So we remove our Dockerfile. We change our command to just use Maven Spring Boot build image, and you can use the Gradle equivalent. And we are going to change the reference of the container image. Then we are going to enable Spring IoT optimization. So Spring IoT optimization have been created for native. They have a side effect. Spring IoT optimization are going to compute Spring Boot conditions at build time. You can potentially specify the profile you want to use, etc. So you can use them, but you will basically freeze the Spring Boot conditions. The value you will get from the configuration are still retrieved at runtime. So if you want to change your JDBC URL, for example, on production, it's okay. You can do that with Spring IoT. But you can't change H2 to MySQL, for example, after computing the Spring IoT optimization. Of course, we are working to try to remove a bit of those constraints, but yeah, it's a bit hard. And then it's good to see that we now have support for Spring IoT at Buildpack level. So be careful, you need still to enable that in your builds. So in Gradle, you are going to add the Spring Boot IoT plugin. On Maven, you are going to configure the process IoT execution. And in order to make Buildpack adding the right Spring IoT enables equals true thing automatically, you can enable that, and you will see after that with CDS that works pretty well. So in order to enable CDS, two main things. We are going to enable that with a flag, okay? BP, JVM, CDS enabled. And the main constraints of CDS is that for some kind of remote services, typically databases, they are doing typically some database connection when creating the bins before the lifecycle is created. And we don't really control that. And sometimes there is connections because, for example, Spring Data needs to get the dialect used, so it will connect to the database to know that. So for each database, you can refine that with a small configuration. So here in Spring Data JDBC, we have introduced spring.data.jdbc.dialect, and you can set it. Usually, I recommend to set that in your regular configuration to be used both for the training run and the regular run, because also that allows you to start your application, and if the database is not ready directly, it can be fine. Up to you. Or you can configure that just for the training run if you prefer. I have put some documentation for basically the various databases that require customization. So Spring Data GPA, JDBC, R2DBC, MongoDB, Redis, Spring Batch, Flywheel, Equibase. We are going to add more of that. Usually it's 2 lines of configuration that either you specify just for your regular configuration, and it will be used for both training and optimized run, or for the Buildpack integration, for example, we have the CDS training Java tools options, where you can just set some specific configuration that will be used only for the training run to prevent remote services connection. Potentially, you may want to connect remote services. Maybe this is what we will do later with Project Leyden to support warming your application, but right now, we are focusing on this use case of you are creating your container image. You don't want necessarily to connect to your remote services because there is no profile-guided optimization. And you just want to be able to do this training run without any remote services available. And this is a use case where we are focusing. So documentation is available here. We will improve the discoverability, etc. It's just all fresh, so yeah. But we are working on other small improvements. It's not just about big new features like CDS. WebJars is a technology that basically allows you to use CSS and JavaScript dependencies using just regular Maven dependencies. And it's a pretty popular technology that is used in Petclinic. And we found, after a related issue was created by the community, that WebJars as startup is slowing down the startup very, very heavily, because it's doing a class path wide scanning every classes, and it's really terrible. So in Spring Framework 6.2, which will be available by default with Spring Boot 3.4, we have this new WebJars locator light. So basically the creator of WebJars, James Ward, Dave Sayer, and myself, we have worked on a better version of WebJars locator core, which is named WebJars locator light. And it does 0 class path scanning, just leveraging conventions, and we are able to support 98% of the use cases. So you should see no difference. And this is the terrible flame graph of the current version of WebJars at startup. It's bad. Okay, it's bad. And it's funny because usually people have the feeling that basically Spring is doing a lot of class path scanning at the startup. In fact, Spring is doing just class path scanning in the application package by default. It's super fast. It's basically 1% of the startup. And when you enable Spring IoT, you remove any class path scanning. This thing, you are going to see the impact. It's huge. So yeah. So now we are going to use all those improvements. We are going to build our container image with Buildpack, and it's going to perform Spring IoT optimizations. It's going to perform CDS training run automatically. So we are building our thing. It's going to create the CDS thing. You are going to see the logs, etc. Skipping a few files, and you get your container. And you can just start it with Docker Compose run. And you can see that basically we have reduced very significantly the startup time, less than 1 second for the application itself. So that's fun. So let's now talk about figures of each steps. Okay, we have seen various commits, various steps to optimize our application. So here we have the startup time of our application on 2 CPU, 2 GB of RAM, because I want to simulate a chip server, so I don't want to use the full power of my Mac. And I start from Spring Boot 2.7 Java 8. Startup time is about 2.4 seconds, basically. I'm going to upgrade to Spring Boot 3.3 Java 21. Does not change that much, but it's an enabler for optimizations. And then you are going to use the unpack mechanism. Of course, you can also use unpack mechanism with Buildpack or extracting that manually with previous version. But my experience is that a lot of people are running executable jars on production, including to do benchmarks with Spring. We enable virtual threads, so we gain a bit because we don't create a thread pool. We gain with Spring IoT, we gain with CDS, and just with Spring Boot 3.3 and those optimizations that are mostly flags to enable, we have a 42% decrease with Petclinic. And if we are leveraging the upcoming Spring Boot 3.4 that will leverage Spring Framework 6.2 with this new WebJar support, you see that the gain is insane just for a library that is expected to expose your CSS and JavaScript file for your application. So yeah. If we check the memory consumptions, so if we are combining Spring IoT plus CDS plus WebJar's locator light, we can reduce the memory consumption after startup by 35%. And you can see the respective gain of Spring IoT and Spring IoT plus CDS, which are quite interesting as well. And so we are doing a bit of benchmarking. So there is a tool I like, it's OA. OA is able to do benchmarks. And here you can see that we are warming up our JVM. So of course, the figures I'm going to show you are not doing this warm-up period. We are going to apply some workload for 2 minutes, something like that, in order to have during our real run that will be used to measure everything, stable throughput basically, and basically better performances. It's basics. It's very obvious for benchmark, but I repeat it because sometimes people don't warm the JVM enough. So for the measure I did with Spring Petclinic JDBC, I have tried to measure various kind of endpoints because that can depend. So we are measuring the throughput on static resources, just a file that is on the class path. We are measuring the throughput for a JDBC template without any caching involved. We are measuring for a cached JSON endpoint, so REST controller with Jackson involved. And we are measuring a cached template, so basically a team lift template that is using a repository annotated with the caching annotations. And basically, we upgrade gradually with the various features. So you can see that, especially with virtual threads, we see a quite significant increase. Here we are on 2 CPU and 2 GB of RAM. And of course, you need to measure that on your application, but you can see that with just a few flags, the performances are quite improved. If we focus on measuring with various instances, because results can vary a lot, and I see a lot of people benchmarking virtual thread with crazy big machine and, oh, I just have 10%. Yeah, but try with 1 or 2 CPU and you will see the difference. Because, of course, when you have unlimited resources, an optimization technology is not going to crazy change your results. But if you are using 1 or 2 CPU, I mean, I have checked multiple times those results. So if I'm wrong, please let me know. But you can reproduce it with the Petclinic efficient container repository. what I consistently found is that with one CPU, the gain in terms of throughput and latency is insane. I guess because with virtual thread, you are going to consume less CPU, less memory. It's a perfect match with Spring MVC and Tomcat. So our traditional blocking stack is the perfect match with virtual thread because we have this blocking execution model that works pretty well. Yeah, I think that's pretty good, and that can allow you to basically use cheaper server with better performance. With more CPU and memory available, virtual thread seems to be still worth to use, even if the gain is more limited. I expect virtual thread to get better and better, so there is upcoming improvement that will remove some thread pinning issues. So yeah, basically I think it's a safe bet, and it will only get better. So Spring Boot 3.3, Java 21, virtual thread, and CDS allow you to use smaller and cheaper instances with better performance. And of course, your melee edge may vary, so test with your applications, benchmarks with OA or other tools. But yeah, this is what we try to provide for you. And I said that virtual thread will only get better. This is also true for CDS. So basically, CDS as class data sharing, I usually call it CDS 1.0. And there is this pre-main branch in the Project Leyden repository that is providing a new CDS feature, which is cache data store. So this is the same acronym, but a different meaning. And I usually call cache data store CDS 2.0. And basically, that will make CDS even better. So the startup time will be even better. Currently, with the pre-main branch of the Petclinic efficient container repository on my machine, I'm able to start basically Petclinic in 0.4 seconds, so pretty fast. I mean, full Petclinic. No, it's not just a simple application. So even faster startup. Warm-up capabilities. So basically, currently CDS is only optimizing memory and startup time. Project Leyden is going to add the capability to warm up your JVM. Maybe not fully like Project Crack, etc. But basically, if you apply some workload to your training run, and that will introduce some challenges because you need to contact your remote services. So I'm not sure if we will handle that via test containers, for example, or Docker Compose, or just your real production environment. Or maybe there is not any more training run, and this is just your real application. But we have seen that it's super handy to have just a self-contained container with everything inside. So I think we will still favor that. But yeah, that will provide warm-up capabilities. And basically what we see in the benchmark we do is that you have half warm-up, basically JVM at startup, and a warm-up time that is very significantly reduced, like you need 10 seconds to fully warm up your application instead of 1 minute, something like that. So I think that's super interesting because I don't necessarily believe into the serverless model where we start one instance for one request, but scale to 0, where you basically shut down your instance after 1 minute of inactivity, and you basically start it when you see a bunch of requests coming. I call it that express warm-up is a good fit with that. And we should be able to have smaller containers. I need to double check it works, but basically your JVM distribution already ships CDS file for the JDK classes. Most of the distribution are doing that to speed up the startup time. With CDS, we are adding an application CDS file called AppCDS, basically the technology. With Project Leyden, we should be able to remove the CDS archive of the JDK when we provide the application one. And so by doing that, you will not grow the size of your container image because we will add the application CDS file, but we will be able to remove the JDK CDS file, and you could even have a smaller image in the end. So we are collaborating closely with the Java platform team. Really appreciate collaborating with them, and we are working together on making that the best possible for Spring application, and potentially to plug that with our Spring Boot and Buildpack support. So yeah, thank you. You have everything available if you want to have my contact on my website. You can go to the Petclinic efficient container if you want to check everything. So check the commits. You have step-by-step upgrades. And yeah, I'm available to answer your questions. Thanks. Any question?
Hi, Sébastien. Thank you for the talk. How specific should be the match between the runtime environment used?
Could you speak a bit louder, please?
Yeah, of course. How specific should be the match between the runtime GVM in the training run? It's about it should be the same vendor, the same patch, sub-patch.
Yeah, so it needs to be, so how close we need to be between the training run and the regular run. The GVM need to be the same. You can't use, for example, the GDK to do the training run and the GRE of the same patch release. It really is the same one, so same patch release, same vendor, the same. really the same. You can...
same architecture as well?
Same architecture as... I think so. I need to double check. With Project Leyden, yeah, it will be the same architecture. With... I think it should be the same architecture. But you need to use the same configuration. For example, when we are enabling both Spring IoT and CDS support with Buildpack, Buildpack is going to use the Spring IoT modes enabled during the training run, because if you do that manually, you can forget. So try to use the same, but it's not like native where you miss something, it's all broken. You can add additional class paths during the regular run. So typically, you can perform your training run with various libraries available, and if you are adding your JDBC driver after the fact, it will just be not optimized for loading the classes of JDBC driver, but it will work if you add that at the end of the class path. Again, be careful about CDS assumptions. We have some tooling available with some logs to check how percentage of cache is used, because typically you should have 90% of cache enabled if CDS is fine, and something like 15% if it's not okay. So you can check that with the logs. You have also some options to make sure that CDS is enabled, and otherwise it will basically not run, even if Oracle don't recommend that on production. But
thank you. Yeah,
so you can add additional libraries at the end of the class path, not at the beginning. Yeah? Other questions?
Yeah. First of all, thank you for the talk. Very interesting. I was wondering, I would like to do some demos in my company. So, what other tools are you using in order to benchmark this? So, you mentioned these OHA tools, but are there others? And how? Just a question. I don't know. How do you simulate like a two processor? Is it in the tool, like?
Yeah, so here what I'm using, can increase a bit. So either you deploy that in your cloud instance, with just a few CPU and memory, and otherwise you can use basically limits like that, where you specify 2 CPUs, memories. By the way, we fixed Buildpacks in order to work correctly with those limits when they are set with Spring Boot 3 and later. So yeah, you can simulate like that in order to not necessarily benchmark your application with your crazy powerful Mac M3, and just you deploy into your cheap Amazon instance with 2 CPU and 4 gig of RAM, and it's not the same result at all. So
thank you.
Yeah. But that will still be two cores of my powerful Mac, so expect lower performance in production. But I think it's reasonably okay to benchmark like that. And yeah, and inside Spring we have an internal benchmark suite where we are basically tracking any regression when we release new versions. So, but that's all internal tooling that we have in the Spring efficiency working group. But yeah, OI is a very good tool, I think, to benchmark your application. And combine with this kind of limitations and scripting to check startup time and memory consumptions. You can do Docker stats, and you get the memory consumption of your container image, or use PS, tier O, RSS, something like that. You should have the metrics. Any other question?
Like here. Thanks for the talk. I like it. Just a question about the training part. When you start the application, you also sometimes connect to database or external services. it's important to connect to the real environment that you will use in the runtime, because sometimes you build one time but use the same image in several environments. What would be affect this training?
With CDS, you don't need to. We recommend to not connect to the remote environment, to the remote services, because again we are starting the startup from scratch, so it's not like crack when you are continuing, resuming the execution. You are starting from scratch. If you miss a few classes because you are not going to exercise the exact same class path, it's okay, because you will just miss 0.9% of the cache. So, I mean, when we will have warm-up capabilities, it will be different, and yeah, to be discussed. I'm not sure what is the right solution, but right now with CDS, I would really advise to not connect. I mean, creating the various beans, not connecting to the remote services, I think it's the right trade-off. For most use case, we don't start Spring lifecycle, so most of the remote connection will not happen. It's just for early database interactions where there is some connections to determine the dialects, GPA, Hibernate is connecting automatically, so you just have to set this connection, but otherwise try to avoid that. I think this is with CDS this is okay.
Thank you.
Do we have enough time to answer more questions? Yeah, maybe 5 minutes. So, yeah.
Hello. Thank you for your talk. Very interesting.
Thanks.
I'm really impressed about the performance peak you can get with virtual threads.
Yeah.
Also with blocking APIs like JDBC or REST template.
Yeah.
But my question is, why is virtual thread not by default enabled in Spring 3.3? So I think every application in this room maybe benefit from this. But why is it disabled at default?
Yeah. So it's about choosing the right time. I think personally, I hope that will be enabled by default. I think it will. I mean, can't speak for the Spring Boot team, and we need to talk about that within the Spring Framework team. But I mean, there is so many applications using Spring Boot. If we switch something on by default, we need to be sure it's okay. And like I said, there is still some thread pinning issues. So there is currently some improvement that may ship in Java 23, not sure, but at least next LTS to totally remove those kind of issues. The JDBC drivers are virtual thread friendly since 1 month, 2 months maybe. There was recent fixes. So I think it makes sense. Right now, it changed the behavior. We recently added support for virtual thread in WebSockets, etc. So yeah, we need to take our time. The JVM ecosystem needs to evolve. Myself, I think for applications after benchmarking, I would use it on production if the benchmarks are okay. And my hope is that later we will enable by default, but it's a bit early to do that.
Okay, thank you.
Yeah, just defensive measure to not break your applications.
Hello, thank you for the speech. But I have such more interesting question regarding like tracing. Like how it will affect Spring OT and like this all CDS stuff when you start to do some instrumentation like open telemetry with the Java agents. So still will be so nice, or it's because of all additional instrumentation will nothing work?
Yeah, so that's a very good question, and I'm not sure about the answer, so I need to talk about that with the Java platform team. I have not tried to use, I think for micrometer, etc. should be good with advanced Java agents. I'm not sure if the CDS optimization are still okay because instrumentation is coming after, or it's going to break some CDS assumptions. I don't know, but we will raise the question with the Java platform team and see, try to document basically how that works with CDS and if there is some changes related to Project Leyden, which is expected to improve. But yeah, very good question, just I don't know. So thanks for the question. Okay, I think we are done. Thanks everybody. Bye.